Hi everyone. Now we are going to discuss about combination of cell. Cells we can connect in the circuit in two types. One is series connection and one is parallel. In series connection, we are going to consider a circuit which is having two cells. The EMF of these two cells are E1 and E2, and cell is having internal resistance. These internal resistance are for this cell is R1 and R2. So this is the circuit. E1 and E2 is connected. E1 and E2 are connected in series. The negative terminal of the battery, negative terminal of the first cell is connected to the positive terminal of the second cell. And EMF of the first cell is E1 and EMF of the second cell is E2. Their resistances, internal resistances are R1 and R2. We are going to consider some points. Consider 3 points A, B, C. The potential at A is VA, the potential at B is VB, the potential at C is VC. So these are the 3 points A, B, C, and here the potential is VA, here VB, here it is VC. First we are going to find the potential between A and B. We can write VA minus VB. So VA minus VB is equal to, how we can write that VA minus VB? We know that the EMF is the maximum voltage that a cell can give, but in the circuit it's not possible. It's a circuit. In the circuit there will be role of internal resistance. So there will be one potential drop because of internal resistance. What is the equation for potential? It is I into R, current into resistance. So in every cell, if we are connecting a cell into a circuit, if we are connecting a cell in a circuit, we are not going to get, we cannot use the entire EMF of the cell. There will be some potential drop inside the cell because of internal resistance, which is equal to I into small letter R. So here the maximum voltage is, maximum potential is E1. We are not able to use that. The potential difference between these two and will be E1 minus IR1, total EMF minus potential drop across the internal resistance. Every cell, for example, if you are taking a cell which we are using at home, the voltage of that cell, EMF of that cell is 1.5 volt. It is written over that cell, written on the cell, but we are not going to get the entire 1.5 volt into the circuit because of the internal resistance of the cell. So every cell is having internal resistance. Because of that internal resistance, there will be potential drop. That is equal to I into R. R is small letter R, which is indicating internal resistance. So here VA minus VB will be equal to E1 minus IR1. Similarly, what will be the potential difference between VB and VC, which is equal to VB minus VC? It will be E2 minus IR2. Now we are going to add these two equations. So VA minus VB, first we are adding left hand side, VA minus VB plus VB minus VC equal to, then RHS E1 minus IR1 plus E2 minus IR2. Here VB and VB, it is equal and opposite. They are equal and opposite. They are going to cancel each other. So it will be VA minus VC equal to E1 plus E2 minus I into R1 plus R2, because we are taking this minus I outside of the bracket and R1 and R2 will be plus. R1 and R2 will be inside the bracket. If you are taking minus I outside, it will be R1 plus R2 inside the bracket. VA minus VC equal to E1 plus E2 minus I into R1 plus R2. Now we are going to change these two cells using a single cell, which is having equivalent resistance, equivalent internal resistance R and equivalent EMF E. We are going to replace that. We are replacing the two cells with a single cell. It is a single cell, EMF is E equivalent, resistance is R equivalent. Now what will be the potential difference between VA and VC? VA and VC equal to EEQ minus IREQ. Instead of this, EEQ is the maximum EMF that a cell can give, but because of this potential drop, on the internal resistance, there will be a reduction of voltage. It will be IREQ. Then we are comparing these two equations. Here VA minus VC is also VA minus VC. Instead of EQ, EEQ, here it is E1 plus E2. So EEQ equal to E1 plus E2. Instead of this REQ, here it is R1 plus R2. So REQ equal to R1 plus R2. It is the expression for equivalent resistance in a series connection of cell. REQ equal to R1 plus R2 and equivalent EMF will be equal to E1 plus E2.